Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem to sum. But before we get started, if you like these videos, please subscribe to the channel. When you subscribe to the channel, it lets me know that you're enjoying the videos and you'd like me to make more of them. Alright, let's get started. This problem says, given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So let's look at the first example. So when we see the first example, we can see that they take the nums of 0 plus the nums of 1, and that adds up to target. So that's the solution. 0 index and 1 index, and this can be in any order. So this is one order that's valid, or if they had 1 here and 0 here, that would be valid as well. Okay, let's look at this next example. So we can see that it's in an unordered state, and that's important. When you read this problem here, you notice it doesn't say that the input is sorted. When you read problems and they don't say that the input is sorted, you should assume that it is not sorted. Okay, let's look at the constraints. So in the constraints, we see that the num's length is guaranteed to have at least 2 items in it. That's important because that lets us know that we're not going to have to worry about checking to see if the nums array is null or if there's at least 2 of them, because it's guaranteed by the constraints. Next, we can see the values of the nums is between negative 10 to the 9 to 10 to the 9. That's important too because when we do our math to solve this problem, we need to take into account if the result is going to be able to fit inside of a integer or not. And we can see that these 10 to the 9s gives us some information. We'll see that when we go write our algorithm that everything is going to fit into integers given these constraints, and so we are good there as well. It says only one valid answer exists, so that's good. We don't have to worry about checking to see if one doesn't exist. But this problem's pretty simple, and when we write the code, it's going to end up working anyway if there if there isn't a one that exists or not. But it's good to know that. So we see the constraints, we see the problem, we understand what's going on. Let's go ahead and work on this conceptually. So here I have this first one set up for the first example problem. What we're going to do is we're going to start I out at location 0, and what we need to fulfill is we need target to equal two numbers from the array. So we can say sums of I plus like some other, number in here. So I'll just say X that will represent some value from this array here. Any value. They can't, any value from the array, and then also this nums of I here. So to make this problem simpler, we can rearrange this equation. We can say target minus nums of I equals X. And if we do that, then when we read this value here, then we can go like this. We can say 9, which is a target, minus 2, which is what we're looking at, equals 7. And then we can say, is this 7 inside of this array? Now, if we just search the array for this 7, then we'll not have a good time complexity. Because if we were to search the array for the 7, then we would end up with a n squared time complexity, which is really slow. The reason for that is because in the worst case, the answer is not even in here, right? So for every time we're at a location I, we would have to iterate through the whole array again. So we would, for example, this one here, we'd say target minus 2 equals 7, and then iterate through this whole array, and then and if it wasn't there, it is there obviously, but if it wasn't there, then we move to the next one and do target minus 7 and see if that is the result of that is in the array, iterate through the whole thing, and then target minus 11 and see if the result of that is in the array. target minus 15, and see if the result of that is in the array. And so for every I that we look at, for every I, we would go over the whole array. So that would be n squared, because it's big O of n times big O of n, which is n squared. We can do better than that. So instead of that, we know that hash maps have a constant lookup and a constant write to big O. So let's make use of a hash map. So how can we make use of a hash map? Well, there's two ways we could do it. One way would be just to iterate through all of this here at the beginning and build up the hash map. So we're not going to do it this way, but I want to show you real quick. We go ahead and iterate through the whole thing and put these values in here. And then, so that's big O of n. And then in a separate for loop, we're going to iterate through this array, which is another big O of n, and do the calculation. So 9 minus 2 equals 7, and then do a constant lookup here to see if the 7's in there. It's right there. So then the answer is 1, and because that's the index of where the 7 was, 1, and the index of where this is. And the big O of that would be this plus that, which equals this, because you dropped the constant, right? You know, this would be like 2 times that, but you dropped the constant. So that would be that. Okay, but we could do better than that. We don't have to loop over this and then do a separate one and loop over that. We could be building up this hash map as we're looping over the array the first time. So we only have to loop once. So how do we do that? Well, we're just going to keep, as we're at this location, we're going to keep track of what we see inside this hash map as we go. So we'll do the calculation and record that 2 in the hash map, do the calculation and record the 7 in the hash map, and do the calculation, record the 11 in the hash map. So let's see, let's do that. So first we do target, which is 9 minus 2, which is 7. Now we're going to ask, is the 7 in the hash map? It's not. So because it's not in the hash map, we'll go ahead and record the one we're currently looking at, which is the value 2 at location index 0. And then we'll increase our I. Now we're going to do target minus 7, which equals 2. And we'll ask if the 2 is in the hash map, and it is in the hash map. So now we're going to return the answer. So 0 is where the 2 was in the hash map, and we're currently at location 1, which has a 7. So this is the answer, 0 and 1. All right, now let's do the second example. Okay, and the target is 6. And we'll clear this out. The I starts over here. And then we're going to say target 6 minus 3 equals 3. We say, is 3 in the hash map? No, it's not. So let's go ahead and record the 3 and the index of where it's at. And then now the I moves up here, and then we say target minus 2 equals 4. And we ask, is 4 in the hash map? No, it's not. So we record the 2 that we're currently looking at and the index of where it is. And then we go to the next one. And then we say target minus 4. Target minus 4 equals 2. And then we say, is the 2 in the hash map? Yes, it is. It's at location 1. Index 1, and the one that we're currently looking at, the 4 that we're currently looking at, is at index 2, so that's the answer. Okay, so now we see how this works conceptually. Let's go code it up. Okay, so first what we need to do is to create that hash map. So we'll create the hash map. Let me get this out of the way here. Create the hash map. Ah, all right. Just one of those typing days. All right, so then we're going to loop over these nums. And then what we're going to do is calculate that x. So we have target minus nums of I. And then we'll check to see if the nums contains that x. And if it does contain that x, then we found the answer. So this is going to be return new int. And we're going to do I and num to index dot get that x. Okay, if we finish this whole for loop and we don't find the answer, then we'll just return null. The constraint said that we're always going to find an answer, so, but this, Java needs us to return something, so we're going to return null. And then, oh, one last thing actually. So I forgot to add something right here. So remember, if it's in there, then we found the answer. If it's not in there, then we record what we're currently looking at. So nums of I, we're currently looking at that in the index. All right, let's go ahead and run this. And I mistyped something. Num to index contains key. I said keys plural. And that passes, and then we'll run it. And that passes, nice and fast, 81%. And sometimes when you run Leetcode, sometimes depending on the, how many other people are running it, it'd be a little bit faster. But anyway, so it beats 81.61%. Let's go ahead and write this in Python now. So we'll hop over to Python. So we're going to use the dictionary in Python, and I'm going to use the underscore style. All right, so we're going to loop over the nums, and then we're going to do our calculation, and then we'll check to see if x is in num to index. And if it is in there, then we'll go ahead and return, and we'll return the I, and then we'll return the num to index at location x. Okay, and then if it's not in there, then we'll go ahead and record it. So we'll say num to index at location nums of I is going to equal I. And then if we don't have any answer or anything, we'll just return none. So let's go ahead and run that. Actually, it shouldn't. Yeah, no, that's fine. We'll just return none. Oh, what did I do here? That's funny. Okay, so then we'll submit it. All right, and that passes. Okay, great. So if you like these videos, please subscribe to the channel so that I know that you're enjoying them. That gives me motivation to make more of these videos. This is one video of a playlist, so you can find that playlist in the description below. Have a good day, and I will talk to you later. Thanks, bye.